Hello guys, I'm Tomas, this is Daro, and this is our workshop that we would like to present to you today. And as you can see in the presentation, it's titled Monolith Sucks, Go for Microservices. So let's see what's going to be on agenda today. So first of all, we would like to introduce ourselves, a bit more about our professional work and maybe a bit about the personal. Then we would like to talk about the monolithic architecture, and Daro will tell you about some of the pros and cons of this architecture, and then I will start and follow up from this topic to the microservices architecture, and I'd like to tell you a bit more about what is it, why is it used, and there are also different pros and cons on that. Also, we would like to talk about patterns and practices which comes hand in hand when developing a microservice-oriented architectures. And then we would like to show you some examples, and we will end with some summary of what we will show you during the presentation and sum up the results. So I guess we can start with the introduction of ourselves. So I'll start first. So my name is Tomas. I'm a software engineer working here for Visma Labs since the very beginning of its existence in Kosice. I have 5+ years experience in software development, and I'm mostly focusing on web development. And the last 2 years I've been developing and studying microservices design. So really enjoying that topic. And as you can see from the pictures, I'm happily married and I have a wonderful child, Tomas Jr. And as you can see in the picture from the right side, I love to drink Long Island. So I also love to watch Netflix series and shows, and I'm a big fan of electronic dance music, and especially the two artists, the Hardwell and the Tiesto.
So hi guys, my name is Daro, not Darius, and I'm also software developer with more than 10 years of programming knowledge and experiences. I have a really big passion for hackathons, attended more than 15 hackathons, allow assembler, microprocessors and low-level programming, robotics. I am long-distance runner, and yeah, I love Mondays and lasagna.
Okay, good. So so Daro, would you like to continue then on?
Okay, let's discuss about a bit about monolithic architecture. Most developers, when they are started working as software engineers, they start working on systems on its own. It is still monolithic architecture because, for example, they started as a single person, single developer. So they don't need nothing complex. It is still a single code base. For example, building artifacts are really just one executable or one process, and the whole system is deployed on one host or virtual machine. It uses single database, and usually developers use consistent technology because why to complicate things? So there's nothing bad with this architecture. It is really something we all started with, and so there is just a question how to improve if something is much more complex. So let's discuss about benefits first of monoliths. It is really simple. It is much more simple than we will discuss about microservices, but there are some drawbacks. So one code base is really easy because even if there is smaller team of the developers, for example 3 to 10, it is still easy to onboard somebody. It is easy to find things because there is just one repository, and it is easy to find anything in the code. Deployment is also really easy. When you want to replace something or upgrade system, it is just one application you have to upgrade. But we will talk about it is not as easy as it sounds. Well, yeah. So Monolith is really ideal for small application or for small teams that still have some problems, has some problems. And the problem is the one of the biggest one is the scalability. If many developers work on the same code base, it can be really difficult to manage how to read history, how to find something what was changed and who is responsible if something went wrong, and how to fix it. Also, if there are many years of development of the complex system, you can have thousands of users and you have to process and analyze really big data. And then it is difficult to improve performance. For example, it is really difficult to maintain because of growing complexity. And there is no easy way how to change, for example, SDK or framework or technology. So you are really, and there is really tight, or it is tangled to the previously chosen technology. And if there is technical debt, and there is still technical debt, it will be just accumulated in the time. So even if you have modularized solution, it will end up tangled, and it will become more and more complex. Yeah, the problem also with the deployments is it is always risky because application is too complex, and even if you need to change single line of code, you have to rebuild whole application. And if something was wrong in your fix, then maybe you can break whole application. And it requires downtime. I really remember we were working 160 developers on a single application, and one build took 40 minutes. And imagine if you need 3 or 4 or more deployments in one day. So the horizontal scaling is also often not possible. You cannot easily just add new machines because you have to then deal with the problems with the database and how to synchronize everything. And you're only many times the only possible solution is just vertical scaling, but it is really expensive because you cannot just increase performance of the single machine and add RAM, CPU infinitely. Yeah, you really need to think about it before this problem will occur. So this is about Monolith. And sometimes there is also distributed monoliths because somebody will tell that, okay, I have more services, but it really matters if it is really microservice or just distributed monoliths. Because if services share the same database and they are really coupled, those services, this is not microservice architecture. This is just distributed monoliths, and this is the worst scenario because right now, as you see on the picture, if you change something on service 1, it will require updates in all other services, also in the database. So coupling is even more tight, and new features require changes everywhere. Yeah, so that's it.
Okay, thank you, Daro. So I'd like to take the point and would like to continue on the microservices architecture to build up what Daro basically said. So as previously noted on this slide, you can see that with a monolith, we can create really a lot of troubles. For example, with the tightly coupled services. So even if you will have distributed services over your architecture, doesn't necessarily mean that you built good microservice architecture because you just created a distributed monolith. So that's the biggest issue when talking about microservices architecture. And it's also one of the key principles of microservices to keep everything loosely coupled. So let's jump on the train and let's discuss the microservice architecture. Let's start with an overview. So the microservice architecture is basically service-oriented architecture. So you imagine that you have a lot of smaller services within your application, which can then communicate over the network. And the communication might be REST API. It can be different communication protocols like AMQP, so for messaging. It can be even different mechanisms. So it also depends on what's your requirements for the communication. As I previously mentioned, we have a loosely coupled elements, which basically means that the services lives on their own and they only take care about the data that they should take care. So we are not messing up with other services. For example, we have a separate databases and we have a separate endpoints to deal with just one element at the same time in the one service. So when we change something in one service, we don't necessarily need to change other services, as Daro previously mentioned. So that comes with much more benefits, especially when it comes to the CI/CD. But let's talk about it later. The next kind of thing is the bounded context. So when you start and work with a monolith in the first place, you will finally realize, for example, if you're having a really big team that you need to go for microservices, you will realize that you need to divide the application into these bounded contexts, which basically means that you have a self-contained functionality within the services and they does not cross each other boundaries. So it's a really difficult process when, for example, moving from monolith to microservices, but it still needs to be done in case that you need to create a really performant and reliable service mesh. So let's go and talk about more about the principles. So the microservices principles states that we should rely on the public API. So that basically means that we will hide the internal implementation of our service and hide your data basically. We also need to focus on well-documented APIs. So that's a very good practice when building microservices to keep everything documented. So we will not forget about anything, and also we will make sure that everybody who's using these APIs are aware of everything what they need to provide to this API or how to use it. Also, a good practice is to use a versioning strategy, especially when you are also having a lot of requirements and from time to time they are changing. You would like to introduce changes in your code, but you would still like to have the old and new changes at the same place at the same time within your API. So that's where versioning came hand in hand, and it's a very nifty thing to implement. So we can have a different versions which you can then use and utilize in other applications. So you then can divide between your, let's say, features. So with the microservices architecture, there is one sentence or one word that you can hear about, and that is the polyglot kind of reference. So with microservices, you can have a polyglot persistence and frameworks. In what that basically means that regarding the data layer, you can have a different database providers. So you are not stick to one, for example, SQL Server for Microsoft, but you still can use different SQL engines for your different microservices because you have a different needs and you have basically different data structures. So that's very good in terms of having data distributed from in other services. And the polyglot frameworks basically means that because we have these communication frameworks that services are using to communicate with each other, it doesn't matter in which programming language and in which frameworks we will implement our microservices. It can be Java combination with .NET, Python, etc. So we are really losing here only by our imagination and maybe the craziness of our management, what allow us to develop. So the other really important principle is about security. So we always need to think about security in the first place and always make sure that we have secured APIs, we have authorization in place, and we use always these principles from the very beginning when designing an architecture for microservices. I have an example of building the microservices architecture where we skipped the authentication authorization for, let's say, for the last part, And because of that, we were rewriting lots of services because we didn't implement it from the beginning. So it's a good practice also to start with this part from the very beginning, so then you make sure that you won't lose any development resources later on. The other good practice is to introduce advanced monitoring. That comes hand in hand for all services, basically, because you need logging, you need the tracing, you need audit trails. So in order to check what's wrong with your services, you need as much logs as possible to identify all of the errors. For example, if your service is down because you implement some changes, you need to know what actually happened. So that's where monitoring is also has its place. And then it's more than just technical transformation. So you don't have to have one big team. For example, when having a monolith, to just take care of one big application, you can have several small teams which can work distributedly over, let's say, cross-country development teams that can work on each set of microservices, and you will be still able to bring a lot of features to your application because you will be focusing only on this small set of microservices. And also there is one very good principle to also automate everything, because when you start with a small amount of services, you are still capable of, let's say, manually deploying your services to the servers. And when it comes that you will have lots and lots of microservices and lots of clients which needs a different configuration, different deploying mechanisms, then you will have a problem that you will need a team of DevOps engineers to kind of facilitate those problems. In order to do that, you need to adopt DevOps principles here, and you would like to build the CI/CD as soon as possible to make your pipeline smooth, and then you can have your services deployed very quickly, rapidly, and have them available. So talking about benefits of the microservices, so as I previously said, we have individual services that are different from other services, so that we have this bounded contexts. So it's easier to scale different set of microservices, and you can then focus on scaling just those which are really heavy used in production. For example, when you have authorization or authentication, you would usually have one microservice which is supposed to handle all those things. So we would like to scale that microservice because there will be a heavy load on that, and you don't want your service to go down. Also, you can rapidly build and release in a cycles your application, and have a more frequent releases to production than going with Monolith, and then everything should be built at one place, so it may take a long time, and so on. Then it's easier to maintain and to evolve the overall system. So when Daro was talking about the monolith, there is this big problem with the evolution and with the technical debt. So the microservices basically resolve this problem because we have a small independent services which are framework independent. They can have a different technology stacks, like we discussed with these polyglot frameworks. So it's easier than to maintain all those technology stacks just for the smaller set of microservices. Then obviously we have a shorter time to add the new features. We have increased agility for the teams, and that's also the same comes for faster innovation. Also, our customers will be delighted when we have a lot more deployments to the production. So this is an example of why the microservice architecture might be really complicated. So this is, if you don't know this reference, it's called the Death Star, a reference to the Star Wars. It's the Amazon microservice architecture. So it's really zoomed out, and you can see that they have so many services they cannot even fit to the image. So they are communicating with each other. So yeah, the diagrams might look scary, but trust me, it's not that scary. So yeah, of course there are some challenges. So when we're having a distributed system, we need to always take care about the performance and reliability. So why we are talking about performance is, imagine that you have, instead of one monolith, which has only a single endpoint, you will now have 3 microservices where you aggregate your data. So this is also a problem because one of the microservices might get down or might be a little bit overloaded, and then you can have a performance problem. So there is also a challenge with that. Then we have a consistency problem. So because we have a different patterns for microservices like that database per service, which I will be talking about in a couple of minutes, you have a problem that you have a data which are decentralized. So you need to also take care about that. And of course, there is operational complexity, for example, deployment, because you have a lot of services, you need to have a lot of pipelines. And that also goes for monitoring. Instead of monitoring just one big application, you are now monitoring, let's say, 30 small applications. And as I previously noticed, the bounded contexts and also division into this context is a little bit problematic from the beginning when you are moving from Monolith. So let's talk about that for a few minutes here. So imagine that we have a system that we would like to create. And let's say we previously had a big monolithic application where right now we would like to go for microservices. So in the very beginning, we need to identify all of the domain models and then create a bounded context. So what that basically means is what you can see in these images. We have a different areas, let's call them the contexts. And then we have a different domain models, which we are using within this context. And as you can see, there are some highlighted domain models. For example, in the conferences management, we have users. When in orders, we have a buyers. In payment, we have a payers, and then we have a customers. So basically, this is the same type of an entity because it's a user, but it has a different name in each context. So now we need to resolve that kind of issue, how to manage this, this user domain model per every context. So as we said before, we don't want to tightly couple those microservices together because then we will be dependent on this user domain model. So instead of that, we can implement user in a conference management and then implement the new table in other microservices, which will only be referencing the ID to the original user table. But there are some more challenges coming to that, which we will talk about soon. But before we go, I would like to then summarize why we should go or when to go for microservices. So as we were saying from the beginning, the monolithic architecture is not an anti-pattern, but if your software delivery is very slow and you need to optimize your development process, you have a very big team and it's just starting to go wrong way, you need more automation or technology stack is obsolete, you should definitely go and check the microservices architecture and start utilizing those changes. So now I mentioned a couple of patterns and practices already during my introduction to microservices, but now I would like to talk about them a bit more and to show you why they are so used generally in microservices and why they are so important. So the first thing that may come to your mind is how would you contact microservices from a client application? So imagine that you have a lot of services that you need to get data from. And instead of remembering all those IP addresses or URLs of those single microservices, you would actually need something like a compositor in your client application or aggregator, which will go and fetch those data. So there is a solution to that, which is called an API gateway pattern. Basically, it's a single entry point, like I said, for all clients. So you can then aggregate or compose your request inside the API gateway into the different services and then return the model back to the client. So the client will be then only coupled with the API gateway. So we will not be coupling client with our microservice architecture because then we are again creating a distributed monolith. So we can have different APIs in our gateway, so we don't have to use the same APIs as we have for different microservices. We can just create a suited APIs for our clients. But of course, there are some advanced scenarios where we would like to use these API gateways. For example, there is this pattern called Backends for frontends. That basically means that for each kind of client, we will expose a different API gateway with a different sets of APIs. So because, for example, mobile application doesn't require to get all of the APIs that the web application needs, because they have a smaller design. They don't need all elements to be visible, so don't necessarily need all kind of data. But of course, there are some drawbacks. API gateway has one big advantage, and that's a single point of failure. So because you are basically exposing your whole architecture to the one API gateway, you also need to take care about your API gateway so it won't go down. And you need to take care about performance, about it needs to be reliable, and also we need to scale it. So that also comes in hand when talking about deployment. You need to take care about the scaling. Then there is another drawback, and it's that you're creating another tier. So because you just created a microservice architecture, now you have a different level where you are accessing those data from. So the other alternative to not use an API gateway is a client-side service discovery. So then we are not coupled to our services, because we are not having them set, for example, in our configuration, but we will just ask someone that, like, give us the API address for this service that we need the data from. So it's basically really it really relies on what's your requirements, and the API gateway is definitely a pattern that's used a lot. But yeah, you need to think about it when you are starting to implement it. So the next useful pattern, which is widely used in microservices architecture, is database per service. As I said, when having a microservices architecture, we have a decentralized data management. And what that basically means is also when we have a database per service, is that we are exposing database to the different services. And because of polyglot data frameworks, we can have a different SQL engines or NoSQL engines. We can have a SQL database for microservice A, and then we can have a Redis database for service B, and so on and so on. So it's a good to have this pattern implemented, because then we can keep the data separately for each microservice. So then we can have and we can persist the data for that microservice and only for that one especially. So also all of the transactions happens only, it only involves its database, and we are exposing this data over the API. So as everything, this also has some drawbacks. So especially when having a lots of data in a multiple microservices, sometimes we need to like synchronize the data between them. So there is one pattern which you can implement, and you can mitigate those problems, and that is messaging, which I will talk about in the next slide. But there is another big problem, like how should you join the data? So you might have tables which are not really related between those two tables, but you need to somehow join the data. And also the next big issue is the transactions. So when you are having operations which are really important, that they must finish with no errors, you need to take care of those transactions somehow automatically. There are also, of course, some patterns. One of them is a Saga pattern. So you can have your transactions running in each microservice, and then if something went wrong, you can then run a rollback command and then roll back all of your operations. There is always an API composition, so you can call service by service and expect the result, and if everything is okay, go and finish the finish your transaction. If not, then of course you need to revert something if necessary and stop your operation. But there are also some advanced patterns like command query responsibility segregation. But let's talk about the messaging for now. So the messaging is the answer to synchronization of data between the bounded contexts. So imagine that you have a complicated order mechanism when you are ordering stuff, and then the site is asking for your credit card. So once you enter your credit card, the payment service, let's say, will be contacting the third party, let's say Visa API, which will then asynchronously will take money from your account and then send the result back to the shop, that if it's okay, or if you, for example, don't have enough money, then it will send you an error. So in that case, you are basically triggering an asynchronous operation, which you are which you need to also reflect you need to reflect on that in your services. And that's where messaging is very handy, because you can have asynchronous messages to be sent to the different services, depends on what is actually happening. So for example, when your credit is held, the order service, or let's say payment microservice, can send a domain event, which will be called like not enough money or something like that, or credit is held. And the different services can be subscribed to that kind of event, and they can reflect with the different operations. For example, if you placed an order, then when received an event of type my credit card is held, your orders will be canceled, and you will be notified about that, for example, on the web page. So that's the biggest benefit of the messaging. And also, when your data is changed in one service, you can send an event, and all other services will reflect on that. So there are very popular messaging clients like RabbitMQ. There's also Service Bus, very popular in Azure environments, and of course Kafka. So go ahead and check those. There are of course some drawbacks. So you need to be very careful about the message persistence. So because it's an asynchronous communication, you are basically sending a message to this message client or to this broker, and if the broker is down, then your message is lost. So it's kind of like an UDP communication. So we need to take care of those messages which are not being sent. And for example, RabbitMQ has this cool setting for persisting the messages. So even if the RabbitMQ will go down, you can have your messages persisted to the file system, and you will not lose any of your messages. So it also brings a bit more complexity to your code, and it might be a little bit difficult to debug and fix the problems, because you have asynchronous calls and you basically need to know your system. So also the understanding of the concept might be a little bit problematic. There are some other good patterns which you should follow, and one of them is the very good it's basically resiliency. So in our synchronous communication, sometimes we have a problem with availability. So there are some very cool libraries, especially for .NET. It's called the Poly, which is a resilience and transient fault handling library. It can do much more things. It can do retry policies and also circuit breakers, which can also develop your quality of services for your microservice architecture. And what that basically means is that sometimes when your services are down, you will want to do a retry, because, for example, there is an ongoing deployment, and between the time when it's being deployed and you are actually contacting the service, there might be just 1 second that you need for your retry, and then you will receive the data to your service back. So in order to do that, you should always implement a retry policy, for example, for 3 to 5 times, trying to retry the request within some timeout. So you will not be retrying like request after request. And also circuit breaker is a very good, useful when for example, when you hit your maximum retry count, you will then hit a circuit breaker, which will basically cut the communication between your service A and service B until the automatic recovery or cooldown will pass, and then you can start to communicate with this microservice. So we'll make sure that it will not be sending any crazy amount of requests towards this microservice. And as we touched previously, there is of course monitoring. So most of the times when you build a microservice-oriented architecture, you always need to be careful and you always need to get as much data as you can to understand if something goes wrong, and if you, especially when you are troubleshooting the production problems, you need a very good source of information to kind of detect those problems. So we also need centralized logging service, and that is also a very good pattern when talking about monitoring, which will aggregate logs from each of your microservice, and so then you can have all your logs at one place, for example, saved in Elasticsearch, and you can use Grafana to kind of show you the graphs, and you can search in logs and to kind of investigate the problems. There are of course other monitoring tools like Application Insights that also comes from Azure, and of course there is Amazon Watch. So there are different mechanisms. You just need to take one and, let's say, implement it. There is of course Docker. I'm pretty sure that you are familiar with Docker, so I don't need to introduce to you. But the Docker is really good in terms of bringing good patterns and tools to your microservice architecture, because you can make your application being independent on the host environment. So basically you can encapsulate your services into your Docker containers, which are lightweight, and then you have a resource isolated environment. So we make sure that there will be no conflict between the services. And as we know, we need also to go for production. So when having everything in containers, we can then aim for more advanced technology. And I'm not going to talk about Kubernetes because the technology itself is very advanced and progressive, but I'll just would like to mention it, that it's, I think, the best tool, in my opinion, for production-ready systems, because it's an orchestrator. So the name itself says that you can have your applications being deployed inside a Kubernetes, and it will take care about your deployment, about your scaling and management of your services. It works perfectly with the Docker containers, and it's being open source, and they are still making a good progress. They are still developing the new features, but it's a bit more complicated. So if you would like to know more, I dare you to go and check their documentation and try to understand the principles. It's a really good topic. So now we have a CI/CD topic, which I would like to then give a word to Daro again.
Yes, so CI/CD, if you compare Monolith and microservices, deployment and integration, as you can see on the pictures, if there is something changed from any team, you have to wait and create release candidate. And if something is discovered that is broken, for example, as you see in the picture from team B, then in the Monolith application, Monolith architecture, we are not able to deploy to production, or if we deploy, we will deploy something faulty. So if we go for microservices and something is not working from one team, then your automated test will just stop releasing this microservice, but all other microservices are successfully deployed, and so we can see those benefits, because when test fails for one microservice, this will affect only this particular microservice. So yeah, you are building only what was changed. It is also really beneficial, because you don't have to rebuild the whole application, what is time consuming and also resources consuming. So this is, I think, self-explanatory. Yes, and Here we can see in the picture, I think the most common example, it is created by Microsoft. And you should, if you are interested in this topic, you should definitely check this example. It is called eShop on Containers. And as you can see on the picture, in the picture on the left, you can have multiple client applications. As we already talked, it is different for mobile applications and for web applications. And you can see also that there is just a single point for all those applications. And then those requests are distributed to microservices. And what we haven't discussed yet more is that few microservices needed to be balanced more because, for example, they are processing huge amount of data and it will require more time. And some of them are just really tiny microservices. Those are called, I think, nano services. They are just microservices processing something really small task, and those just maybe you will need to have multiple instances of those microservices. So this is also something really really good to know, that your load balancer here in this architecture, microservice architecture, is much more easier to implement. And also we can see that all those microservices communicate over even bus, and yeah, they are just exchanging those messages. So this is a really good example. You should definitely check this, but we have also another example, but this will discuss Tommy.
Yep. Okay. Yeah, so we can go to the previous slide. So what I would like to show you here is example of microservices based architecture, which we are working here at Visma, and we created basically microservice architecture. We have an internal tools that we are using. We have a different clients. We have a client for our recruitment office. We have clients for our employees, so they can submit all the referrals. Also, we have an identity server which handles all the authorization, authentication stuff. But because this is only 1 hour workshop, we don't want it to code anything here, because just not a lot of time to develop something. So I would like to just to show you how that actually looks just from the global perspective. So we won't go very into the details. So we have this repository. It's hosted in GitLab, where we have also CI/CD set up. And as you can see, the project is constructed from totally of, I think it's like 36 microservices at all. And we have a different, we have a structure here which handles, we have an application gateway here. So we can see we have a main gateway, and then we have these aggregators, which we use for different application bounded contexts to join the data from just, let's say, those contexts that we need. So we don't use the general gateway, but we have a different one for multiple scenarios where we need them. And as I was saying from the beginning, we have the bounded contexts, which in this case are basically applications. So every application is its own context. But for example, the recruitment context has also more than one microservices. So we have the main microservice, which contains like the main data about candidates, about open positions in Visma, and like ongoing interviews and stuff like that. But we also have an archive API. So instead of fetching the data from the main API about the candidates who have been processed here, but they are now closed, or we have an employees because they started to work here, you can load the data from the archive. And as you can see, we have a different APIs for reports and statistics. It's also good practice to have like I said, when you identify your domain models, you create a domain project which is only available inside your bounded context, and it's very useful also when having a much more microservices in one bounded context. And then we also have the client projects, which I was talking about in the separate folder, which is called the web apps, but it's basically, it can be MVC applications or Angular applications. So here we have also division by bounded context, and then we have a specific client, which are basically .NET Core 3.1 clients, which then we are using to provide the UI for our employees and for our recruitment office and etc. So we have all of these things implemented here. We have lots of patterns and tools used, like I was discussing, like database per service and messaging, identity server, second level caching for better performance, which I didn't talk about, but I can mention right now. But yeah, let's get back to our presentation, and let's talk about the deployment of microservices.
Yes, everything is written in this slide, so you can see that the manual deployment is really a step-by-step guide, and it is something you may go for just if you are working as a single developer, because in a few days or weeks you will be really overwhelmed by the step-by-step guides of the deployment, and it is really error-prone process. Something small can lead to bigger problem, and this slow and inefficient, of course. But if you automate everything what you can, then you can have frequent deployments, and those are not problem. Even many deployments in one day, and those are reliable, repeatable, and also, as Tommy said, everything is logged and monitored. So if something went wrong, you can really easily find what was bad and what was wrong, and you can fix it as soon as possible. Yes, and also continuous integration will give you a benefit of building and running tests. So if there is something really small problem, you will see it in a few seconds, and then you will not break whole application, and even your microservice is still safe, because this deployment will stop before it was deployed to production.
Okay, so we get to the point where we'd like to summarize what we've been talking about here together with Daro. So basically, we discussed briefly about the monolithic and microservice architecture. We discussed about the pros and cons, and like we said, the monolithic architecture is not really an anti-pattern. It's definitely something that you will probably start with, and over the time you will probably switch to the microservices because of complexity of your system, and maybe you will need to utilize changes more frequently, and you will need a faster deployment. But maybe monolithic is the right choice for you as well, especially when having a smaller applications. It doesn't really make sense to split into the microservices, because then you are just creating more complexity than you are actually benefiting from. So you need to really carefully think about your decision why or when to go for microservices, as I was showing previously. So it's definitely one of the architectures that I see in the years when I started to use it, that it has a really great potential, and especially for very complex system, and for all those benefits that we talked about, is definitely one of the progressive and really cool architecture designs, where you can also gain a lot of experiences with the different technologies, different communication protocols, and you can solve a lot of different problems. And if you are kind of person which loves to solve these these problems with infrastructure, with the different communication scenarios and designing architectures. If you see yourself at this point, you should definitely go and check out the microservices architecture. So that was it. So we say that we're having fingers crossed from our Visma team here in Kosice. We wish you all the best and best of luck for solving the challenges. You can also find us on the Facebook. The link is down below. It's basically Visma Kosice. And you can also find us on the web. So you can read some information about Visma. But yeah, thank you very much for your attention. And
if you have any questions, you can still reach us on Swapcard and,
yes.
Slack, and you can ask whatever you want, because right now it is a bit more complicated when it is online.
Yeah. So thank you guys again for your attention, and see you at the Swapcard. Yeah. Thank you.
Like it.